our last talk today, leveraging near-field communication and cross-platform mobile applications to simplify the configuration of IoT devices and services. This will be presented by Mohammed, Kenana, and Johan.
Okay.
Hello, everyone. Hi.
Hello, everyone. So today we will be presenting our senior design project, which is titled Leveraging NFC and Cross-Platform Mobile Applications to simplify the configuration of Internet of Things devices and services. My name is Kinan Adelle, and my colleagues are Joanne Medina and Mohammed Souj. So first we will be presenting the problem statement and the proposed solution. After that, we will talk about the literature we reviewed and the requirements for our project. Then we will talk about the methodology and experimental setup. Next, we will talk about the general architecture and the prototype of our project. After that, we will talk about the security aspect. And then we will mention the potential use cases and the stakeholders. And lastly, we will talk about the conclusion.
Okay, so Chapter 1 covers the problem statement and proposed solution. Internet of Things is one of today's fastest growing trends in technology. It involves the communication of things to the internet by having microprocessors embedded within devices that can send and receive data. Commonly, these things are referred to as smart something and can be any object you can think of. We now have a smart TV, a smart fridge, a smart chair, and the list continues. These objects are usually controlled and configured using mobile phone applications. Some of the common challenges related to this, however, include downloading multiple mobile apps to control different IoT objects, counterintuitive user interface, and the risk of a breach of security and privacy. For example, if you want to access your TV from one app, you might have to access your washing machine with another. And if your phone memory is full, that could be a problem. Moreover, there is an underutilization of NFC tags that we can actually take advantage of, as we will discuss in this presentation.
Our project aims to solve these problems mentioned by my colleague Joanne. The Internet of Things is widely expanding and with many devices to configure. Our project proposes a solution to that problem by creating a universal Internet of Things mobile application. We call it universal because it is completely decoupled from the device it needs to connect to. So our project proposes the idea of having an application that is initially independent from any device, but then becomes completely familiar with it. This is done by having support to common communication protocols like Bluetooth and Wi-Fi, and through Wi-Fi we can communicate using SSH capabilities as well if need be. The application will not have anything related to the device unless you tap an NFC tag that is attached to that device. Once you do, the application will have a look and feel that is associated with that device and establishes the proper communication protocol. The user interface and functionality are different in every device and entirely created by the manufacturer of that device.
In this section, we will present the literature we reviewed along with the requirements of the project. We reviewed literature that we found to be similar to what we are trying to implement. Two of those papers are related to using AR with IoT devices, while the other three papers focus on NFC technology with Internet of Things. The first paper mentions an implementation of an AR-based model that uses Microsoft HoloLens to configure IoT devices. Their project uses a VR headset to make a fully immersive experience for the users, for them to create workflows and connections between their devices. The second paper presents an AR application that can show information about a device. It requires a middleware that is placed over the operating system. The third paper talks about challenges faced while using IoT devices and how NFC technology can help solve these challenges. The fourth paper that was reviewed presented a secure and easy-to-use method to configure IoT devices using NFC. The paper discusses several approaches which require a back-end server to store the device's firmware. And the last paper shows the ability to have privacy protection for NFC communication by using certain security protocols. Next, my colleague Joanne will talk about the requirements.
So this project has three major requirements from the beginning that set as a guide on how the whole architecture will be structured and implemented. Those three concerns of fully decoupled functionality, security, and the user-friendliness of the application. Each of these requirements are equally considered with high importance in the implementation of our project, and we aim to find a common ground to make them all happen. By decoupling, we mean that the app is universal and can work on all IoT devices. We don't want our app to be device specific, as that's the problem we were trying to solve in the first place. Moreover, we aim to make configuring things more intuitive and user and age friendly. A router is not something everyone understands, especially for non technical or older people such as our parents. The simple act of changing the password or the router name may seem impossible for them without seeking professional help. What we aim to provide is a platform that can make this task easier for them by doing so in one click on their phones. Also, security is very important as we all are aware of, specifically concerning IoT and NFC. The privacy of our users is therefore kept in mind during the whole development of the app. How we achieved all these requirements, challenges we faced, and all the trade-offs we needed to do will all be discussed in this presentation.
This is a table comparing other literatures with our project results. The columns represent the features, while rows represent the literature respectively. The last row in this table shows how our project compares with the literature. Based on our research on idea stimulated and literature review, we started to see how the research is lacking in creating a solution that deals with the requirements that are needed. The requirements mentioned earlier by Joanne are found based on what we found missing in the field of IoT. As you can see from the right column, all of the research papers and articles that we looked into are IoT related. However, our solution is the only one that innovates on the idea of decoupling. Separating the mobile application from the device makes the project application agnostic, meaning that we can connect to any device with any specification with just a simple NFC tap. Now we do this while maintaining secure and fully utilizing on the NFC capabilities to configure IoT devices as shown in the last row. From our project, you might have noticed the yellow tick under AR. We have experimented with augmented reality and found a lot of potential with incorporating it into our project, as we will show in the later slides. But we made the decision to have it as a future improvement as functionality was more important for our limited time. As you might have also noticed, we did not implement a back-end server. We take full pride in that as our application works completely offline without the use of internet, and we consider that as part of our innovation as all IoT applications on mobile phones require internet connection of some sort.
In this section, we will talk about the methodology and the experimental setup that was required to start off our project. So to set up our application, we researched different tools and platforms that we needed to help us achieve the requirements. React Native was the chosen platform for developing our mobile app, as it allows us to implement a multi-platform solution that works across multiple devices. It also supports various plugins and libraries that are useful for our application. NFC technology was also looked into, as we required specific requirements from the NFC tag. It was an important element in our project as it was used for the decoupling aspect. More on the specification will be mentioned by my colleague Joanne in the upcoming slides. The router was our use case for this project, and that required us to use the OpenWRT firmware. In order to have more flexibility and control over the router, also over the use of SSH. We used a Linksys router that is compatible with the OpenWRT firmware. Next, we looked into WebView and HTML, as that is also an important part in decoupling. Plugins for WebView component were researched to find ones that can properly rendered HTML, JavaScript, and CSS code, along with proper support to the functionalities that we need. For AR, we experimented with multiple tools like React Vero and AR.js. My colleague Hamad will explain more about our AR test.
As mentioned earlier, the idea initially was to have a user interface that is completely made of AR elements. As you can see on the image on the left, we have a hero tag in the real world that the AR component can detect and anchor on. The tag will then have the AR components on top of it that resembles the information of the device that is connected to. This is an example of a router, as you can see. We have then realized that we wanted to make our application decoupled, not having any device contents stored into our application at all, but only in the NFC. This is when we started to run into challenges with this idea. We had a couple of options for augmented reality to be compliant with our project. On the image on the left, we use AR.js to create the AR objects, which is an HTML browser-based application. This option seemed achievable as we use a browser-based implementation, as you will see in the later slides, called WebView. However, WebView did not have support for a major component called WebRTC that allows access to specific hardware in the phone, such as the camera. We then attempted to run the AR natively in the application using a library called React Vero. The result is shown on the image on the right. However, with complete decoupling, this was not possible as there is no ability to render and compile code that contains a 3D object after the fact that the application has begun running. So we believe that there is a way to implement this AR ability, and we have found a way, and there is a way towards that. We found a way to do that towards the end. But we reached the idea that could work and decided that we need to use our time wisely and focus fully on the application functionality for our project and include the innovative concepts of decoupling and offline use.
So here is the list of all the hardware devices and software tools we use. Let me start with the hardware. In the beginning, we got MyFair Ultralight and Classic 1K NFC tags from the university, and we initially used those for testing how to read and write to NFC tags from a mobile app we developed. We later realized that those two can only contain such a small amount of data. MyFair Ultralight has a memory of 64 bytes, which is definitely not enough to store the content we need and implement full decoupling. Classic 1K has 1 kilobytes of memory, which was also not sufficient enough. Therefore, we purchased a 32 kilobytes NFC tag, which is what we used in the project. OpenWRT router is the device we want to configure as the initial use case of this project. iPhone X or newer with iOS 13 and Android phones with ARC core are needed for running our applications. Lower models do not support reading and writing to NFC tags, so that should be taken into consideration. Moving on to the software tools, we used React Native for the development of the app, as mentioned earlier. And here are the most important libraries we used. React Native NFC Manager was used for reading from and writing to NFC tags. React Native SSH was used to connect via SSH to the router. React Native WebView was used to render HTML, CSS, and JavaScript within the React Native app. The React Native AES crypto was used to encrypt the whole content of the NFC tags, while React Native hash was used to hash the password written on the NFC. Xcode was used for building the app into my iPhone and Android Studio for Android phones. We used Atom and Visual Studio for writing our code. GitHub was also used so that we can see and share our code easier and faster, which was very helpful during this quarantine period. Despite the challenges related to social distancing, we took advantage of many online tools, including GitHub, that allowed us to continue working simultaneously, which I'm very proud of with my team. Next, we move on to the general architecture and prototype. This is the general architecture of our project. Step 1. Once you open the mobile app, it will prompt you to log in with a username and password, and then the NFC tag would need to be scanned to continue. This step is essential for authentication and setting up a connection with the device. This step performs reading from the NFC tag to check if the user is saved as one of the authorized users. After this step, the app will proceed to either of the two stages 2A or 2B. When no previous NFC scans and initialization has occurred, the user becomes an admin to the device as in 2A. Once an admin, he will have the authority to add users that can use and configure the specific device with respect to the NFC tag as in 3. Another scan is prompted in this case to update the contents of the NFC tag and they can have access to the device then. If an admin already exists, on the other hand, as in 2B, the app will check if the user is authorized by the admin and thus should already be written on the tag. If the username and password are not registered on the app, the page will stay on the login page and no further actions can be made by that user unless he logs into another verified account. If he is a registered paired user, however, he will be taken to the WebView or HTML page where he can view information and configure the device with an established connection as shown in 4. It is important to note that only the admin has the privilege of adding users that can have access to the device, and that all these information is stored in the NFC tags and not in the app itself. The only data stored in the app is the login page and the additional add users and scan page if you are an admin. Everything after that is rendered based on the contents of the NFC tags, thus the whole point of decoupling. In this project, a router is used as the main prototype for testing, wherein information is displayed and the ability to configure is available. Next, Mohammed will show our project interaction diagram.
To further elaborate on the main architecture of the application, we created this object interaction diagram. The object interaction diagram describes how the objects of the application collaborate. This is a sequence diagram, as you can see, of the project. The sequence starts at the sign in where the user enters their credentials. After that, we move on to the scan NFC where most operations take place from this point on. We can distinguish at this state where the user becomes an admin, is an admin, or the user is not an admin and logs into the device immediately. In the case that there is no admin method invoked and make user admin is initiated, and the user becomes an admin, the admin of that device. The credentials are stored back into the NFC using 3A write to NFC. If the user credentials are the admin can then add a new user as an optional step before entering the device main screen. If the admin adds a new user, they will enter a new screen login credentials and the add new user method is invoked. When a new user is added that way, the new username and passwords are written back into the NFC card. Otherwise, the admin or users log into the device and the device can be configured as well. Notice the device configuration is the same whether the user is an admin or not. The admin privileges are only allow the admin to add users or not.
Now I will share with you how we implemented reading and writing to NFC tags. The React Native used for the development of this mobile application that uses the NFC technology is React Native NFC Manager. This library accepts 10 different NFC technologies for both Android and iOS, which is based on the type of NFC tags available. Different NFC technologies make use of different commands, therefore changing our code from MyFair Ultralight, which the library accepted as MyFair iOS technology, to a MyFair 1K, which the library accepts as using NDEF technology, requires a complete rewrite of code. This was a challenge that led to the realization that our app can only accept one specific type of tag. After thorough research, testing, and debugging, reading from and writing to a 32 kilobytes NFC tag was made possible using the NDEF technology from the NFC library used. This tag stores up to 32 kilobytes of data, which meets the requirements of our project, and is expected to contain HTML code without compromise. Snippet of the code implementation of writing to NFC tags from React Native is shown on the slide. This line specified what NFC technology the phone should expect to receive, and it shows this pop up on the phone. This line converts text we want to store in the NFC to bytes and actually performs the writing. The same procedures are used for reading from NFC tags. Next, I want to talk to you about what's stored on the NFC. Basically, it is what's shown in this figure. It starts with a header, followed by the HTML, CSS, and JavaScript code that contains the device functionality and user interface. The header starts with the device name, followed by the connection type. Supported connection types include SSH, Bluetooth, and Wi-Fi. This is important to specify as it tells our app how to communicate to the device. In the case when SSH is specified, 3 parameters should follow, namely the router name, host IP, and router password needed to connect to the router. Next, we specify the paired devices for user authentication. The paired devices are represented in an array where the first user on the array specifies the admin. The passwords are hashed to add an extra layer of security. Most importantly, note that this whole text is AES encrypted, and we will show you the importance of that in the later slides and during our demo.
So this is part of the actual NFC content that was just mentioned by my colleague Joanne in the previous slide. This code includes HTML, JavaScript, and CSS elements that altogether are rendered to display the relevant information and also configure some settings. Initially, the code will hold the commands that will be sent via SSH in this case to the router, and then the result will be replaced by the command in code and displayed in that same place. A simple example to show how the application parses the input and shows the information is as follows. We look for $2 signs in the code. After finding them, we parse out the command between the $2 signs. The command is then sent through SSH to the router, and the result is sent back. The result is then replaced by the command, including those $2 signs, and then the content is rendered to display the page with the right information. The configuration of a router required a library in React Native. The React Native SSH library was used to send commands and receive their outputs like any normal SSH session. The function used in our code to establish a connection, send, and receive data is shown on the slide at the bottom. SSH execute takes as input parameters the configuration, which includes username, host IP, and password. And the command that we want to send, which in this example is LSL. The function will output a result in a callback, which will show the result from the command. In this case, the result will contain a list of all the files and directories that are present in the directory that we call this command. Another property that was used via WebView component was the post message and on message properties. These were useful for communication between WebView and our native application, which is React Native. It is mainly used for allowing configuration. Here's an example of how it is used. The user puts in an SSID and hits apply. WebView sends a message carrying the command requiring the change of SSID along with the user input to React Native app. After that, on message is called, and then the application sends the message to the router as it is via SSH, and then the changes are done. Next, we will talk about the security aspect of our project. So first, to maintain security in our implementation, we included encryption and hashing. The user passwords that are used for authentication purposes and that are stored on the NFC header are hashed. That is to prevent anyone that might have access to the data to view the passwords. The function shown at the top is how the hashing is implemented. It takes in the password and the hashing algorithm. which in our case we use KCAC or SHA-3, and it outputs the hash. The next step done was that we encrypted all the data that will be stored on the NFC using a private key that is only known by the application and manufacturer. The encryption algorithm used is AES encryption, as previously mentioned, which is one of the most secure algorithms. The functions to implement the encryption are shown below. The PBKDF function takes in a password, salt, a cost, which specifies how many iterations are needed for the key, and the length of the key. This function generates the key that we will use for encryption. The encryption function takes in a text, a key, and an initialization vector or IV that is generated randomly every time we encrypt. After encryption, as the ciphertext and IV are returned, both of these are stored on the NFC tag as well as will be shown in the next slide. With decryption, we use the same key along with the ciphertext and IV to get the original plaintext. Here we can see what is actually stored on the NFC at the top, where we have the IV and the ciphertext after encryption. And at the bottom, we have the plaintext that is shown after decryption.
To elaborate on the security method used, we show here 3 use cases that can allow and deny user access. First, a pseudocode is written to understand how the admin is determined. When the NFC tag has not been scanned since it was sent to the customer, the first scan with the application determines an admin. This device becomes the admin with their username and password stored and written back into the NFC. As you can see in this example, John scans the NFC with his credentials and he becomes the admin and gains access to that device. The NFC then updates the credentials and the number of paired devices with this device. This allows John to access the device by scanning the NFC tag using any smartphone. John only needs to enter the correct username and password credentials, and he can have access and configure and control the given device. Use case B, however, contains the pseudocode for authorizing the user with access if they have the correct privilege. If the credentials do not match the user list and password of the NFC tag, then the user access will be denied. This is shown as the user Tom here tries to access the NFC tag with unauthorized credentials. If the access is denied, then the user will not be able to enter the device associated with the NFC or even modify the contents of it. When Tom enters their username and password, their credentials are checked with the NFC list of credentials. As the list of credentials only contain John's information hashed and encrypted, Tom will have no access to the device whatsoever. Tom cannot even read the NFC contents using his app of choice as it is completely and entirely encrypted. The security method implemented here allows the device to only be accessed by one user and only when the user is physically next to the device. The device cannot be granted access remotely because the user needs to physically scan the NFC tag and the authorization happens instantly. And as I mentioned earlier, there's no back-end server, so everything happens locally and offline. This is a crucial part of the project to make sure that only the correct user can access the device with the right username and password. The username-password combination allows the user to log in using a different phone and still have access to the NFC tag. For an example where a user would lose their phones or it would not work anymore. Use case C demonstrates that by adding credentials to another user, the other user can then access the NFC contents as well. The pseudocode here shows how you can add a new device after verifying that the admin is logged in. This is only possible when the admin logs in. While the other users log into the device, they have all privileges of controlling that device except the privilege of adding any new users further. That capability is only allowed by the administrator.
Next, we move on to the potential use cases and stakeholders. The complete decoupling of the app with the user interface from the NFC tag allows it to be universal, therefore, the sky is the limit for the potential use cases of this project. The future vision is to have a full home, office, and university automation system where users can control and configure IoT devices from a single app, given that those devices are equipped with their respective NFC tags. It has been proven from this project that given a standard or a protocol on what is stored in the NFC tag, our app can render and perform tasks as needed. Therefore, if it works on one device, it can be simple to implement it for multiple. One of the scenarios that could be accomplished in the future involves a smart meeting room system for offices or universities where our app would allow bookings, reservations, inventory, and full control on the devices inside. Users can scan an NFC tag from outside the meeting room that contains information about its availability and devices available from the inside. Time slots will be displayed on the app, and booking reservations can be implemented to simplify the process. Each device inside can either have their own NFC tags to allow access and control, or this feature can already be enabled automatically once the booking has been confirmed. This option is debatable for security purposes.
Initially, a meeting was established with the Successful Engineering Solution Corporation that's located in Qatar Science and Technology Park. These were our initial stakeholder meetings. So, engineering solutions create multiple applications that pertain to virtual and augmented reality. The company creates educational solutions such as using a fire extinguisher to put out fires in virtual reality, or learning how to drive a car even. In that meeting, the ideas for this project were discussed, and there was an apparent interest and enthusiasm from the company. Engineering Solutions suggested that the focus needs to be on one device and not multiple devices at once. That was kind of the idea initially as we were starting, but things kind of deviated and changed throughout the way. So throughout that meeting, there was a bond established between us and them, and it was clear that future communications will lead to much greater benefits. We then decided to visit the most inspirational technology event in Qatar, KitCom. At KitCom, we got to meet Blue Links, which is another company that specializes in taking advantage of augmented reality to make educational illustrations of objects in the world. They showed us a demonstration of a human heart that can be seen through an augmented reality camera, as well as the anatomy of a small animal such as a frog. This was an inspiration for us to create custom tags of AR markers and utilize on that technology for learning purposes. Meeting with Blue Links opened up an opportunity for future communication as the development of this project was in an early phase. As our project geared towards IoT devices later on, Kogi Consulting Corporation, an IoT designing company, was an interested candidate for a stakeholder. There was a conversation with the business development director regarding this project, and it was conveyed that the company can become a relevant stakeholder for the project. We agreed on further communications with all stakeholders as the project comes to a stage ready for demonstration. Today, we have reached this point, and we plan on reaching out with the stakeholders with our demos as well.
In this last section, we will be concluding by stating the requirements, the trade-offs, and the future developments. We have met most of the requirements that were shown in the beginning of the presentation. Adding the NFC and WebView components allowed us to achieve the decoupling requirement. With password hashing and NFC content encryption, we were able to achieve security. With some work with AR, along with HTML WebView component, we were able to achieve an intuitive interface. Although AR wasn't an element that was integrated within our application, a lot of work has been done on designing and implementing AR solutions. However, we found difficulties integrating the elements together given the time limit, so we decided to work on improving on what we have and achieving intuitiveness through WebView and HTML components.
Three requirements guided the development of this project, namely decoupling, security, and user-friendliness, as I discussed in the beginning of this presentation. Challenges were faced throughout the duration of the project that led the team to prioritize some things over the other. First, months of research and coding were spent for implementing augmented reality to account for the intuitiveness feature of the app. As explained, however, this was not possible if the mobile app needed to be device agnostic. Therefore, the first trade-off is rendering HTML, CSS, and JavaScript instead of AR to implement the fully decoupled user interface and functionality of the app. We prioritize decoupling over user-friendliness in this case. Another challenge faced concerned the security requirement. Our app does not store anything locally and depends its whole functionality on the NFC tags. Therefore, it works even without internet connection. It does not have a backend server to store any information in its current release, but that is planned to be implemented in the future developments of the project. Given that, user authentication is based on the NFC tags still, which can be vulnerable to hackers who get a hold of the tags. In the current release, the content of the app is indeed encrypted such that no external app can read the true content of it. However, since we are reading and decrypting the text stored in the app before authentication, our data becomes vulnerable to RAM or memory dumping. Hackers can use our app to read the contents of the NFC while monitoring the memory of the phone being used that can expose the decrypted content of the NFC tags. This is a limitation of the app that the team tried to approach by implementing double encryption. In this approach, the first layer of encryption is decrypted using the key common to the app in the NFC tag. This way, when an unauthorized user tries to log in and read the memory, the content would still be garbled bytes. The key to the next encryption would ideally be the hashed password of the user. There can be multiple users for a device, however. This implementation of using a hashed password as key would limit those number of users to one. It was then decided that double authentication will not be implemented for now. Instead, better user authentication shall be implemented in the future by utilizing a backend server. In that way, user authentication will occur first before the scanning of the NFC tags, which minimizes the possibility for memory dump from unauthorized users. This leads us to sharing our future developments. In the future, we hope to get rid of all the trade-offs mentioned. We aim to implement AR for better intuitiveness, provide an online database that can be used for better user interfaces and experience, as well as have a better user authentication process. We also hope to expand the prototype by having more devices actually connect via Bluetooth and Wi-Fi. And that concludes our presentation. Here are our references, and now we will show you our project demo. Demo of our senior design project, which is a mobile app developed using React Native and uses near-field communication technology to configure IoT devices. And in this demo, the IoT device that we're going to configure is an OpenWRT router. So what I have on my screen is a terminal to show you what is happening on the back end of the application and my mobile phone. So let's start by opening the app. It's just building right now. Okay. So the first page of the app is a sign-in page. Anyone can sign in, but the authorization to the next pages of the app depends on the content of the NFC tag. So let's start by putting in my credentials. And when I click continue, it's gonna ask me to scan the NFC card. And I scan. And as you can see, what I am reading from the NFC tag is this fully encrypted data. So as you all know, there are available mobile applications on App Store and Google Play that can read and write to NFC cards. And in that case, if they read our card, this is what they're going to get. So all the data, all the content, and the header of the content of this is protected. What our application does is it has the specific key to this encryption. And so we decrypt the text, and what the content has is a header and the HTML code that the application will render. This HTML code can be anything, but this header is a standard from our side. So what this header has is the name of the device and the connectivity type. The connectivity is important to be specified because that tells our application how we can communicate with a device. And in this case, since it is a router, we are communicating through SSH. And then we have here the number of devices paired and devices paired ID and password. Only authorized people can have access to the app, and they are specified here. Since I am the first one to scan this tag using the app, there's no admin yet, and there are no other users yet. So when I click on continue, it's going to ask me to scan the card again. And that process writes to the NFC tag that I am now the new admin because I am the first user who scanned this tag. And as you can see, devices paired ID is Johan, my username, and the password. The password is hashed on top of this fully encrypted data. So we have hashing and encryption to secure the data that we are storing on the NFC tag. That directs us to the web view wherein we can configure the device. In the connected devices, this is real time. Therefore, I'm going to connect my other laptop and you're going to see it pop up on this page.
Hello everyone. As you can see on this page, along with the SSID, we have the list of connected devices and the routing table, which shows the destination IP addresses of the packets, and the network traffic shown at the bottom. The connected devices table is dynamic, which means that when a device connects or disconnects, it shows immediately, as you can see now. The network traffic section shows the monthly and daily average of received and transmitted data in megabytes, and it shows the average rate in kilobits per second. This is important as it can tell us if the network is busy and can give us an insight into why there might be a decrease in the speed of the network, for instance. Now we will move on to changing the SSID. Here we can see that the router's original name is My Home Wi-Fi. We can change the name to, let's say, FYP Wi-Fi, and then we hit on apply, and it shows this message saying that we need to restart the router for the changes to take place. So we reboot, and the Wi-Fi settings should change.
As you can see, the router's SSID has been changed from My Home Wi-Fi to FYP Wi-Fi as shown over here. Now we're going to show you a demonstration of logging in using an unauthorized user, so a credential that doesn't exist in the application array. So I'm going to do this by logging using my own credentials. I haven't been added yet, so I'm going to attempt to log in. My username, and I put in my password. And once I do, I can scan the NFC card. And then I get this pop-up that says alert not a valid user because my username or password has not been added into the username array of the application. As you can see here, Joanne, her username being the admin and her password hashed into the application is the only username and password that is stored into the NFC. So in order for me to be a valid user, the admin Joanne needs to add me.
So only I have access to the device right now since I am the admin. But the admin can add users for authentication. So I'm gonna log in the same way. It grants me access and took me to this page. Only the admin has access to this page where I can add users. And I'm gonna add Muhammad.
So as Joanne is adding me as a user, she's using my username and my password that I provided her to add me as a user. Because she's the admin, she would need to scan the NFC as shown to write into it my username and password information, credentials. So this gives me the authority to be able to log in as a user. As you can see in the back end of the NFC, we have the devices paired ID, Joanne and Muhammad, myself, as long with our passwords being entirely hashed. And the whole NFC content is on top of the hashing is also encrypted as a whole. So this allows me to access the NFC content and allows me to access the device that's paired to it and to control it as however I need. For example, now that I am logged in, I'm gonna change the password for the router. So if I were to change the password to something else and then hit apply, and then it tells me that the router needs to restart, so I click OK. And in this scenario, I'm gonna restart the router manually to give a different test case. So I'm gonna restart the router, and as I turn it off and on, you can see that we got a little pop-up at the end that's saying that the application has been disconnected with the router. So we will go on to the settings and we will try to connect with the router again. And then when we do, we will notice that it will tell us that the password is incorrect because we just changed the password. So I'm going to enter the password that I changed the router to. And this is one of the things that our application allows the communication and configuration of the router. So now I can go back into the application and I can log in and scan my NFC. And once I do, as you can see, it gave me all access to the application, and I can configure it the same way as the admin. Any other user can configure it similarly, and this is kind of a demonstration of adding another user into the application.
We have two other tags. We support connection for Bluetooth and for Wi-Fi. Okay. Now I'm gonna exit this app. We will start with Bluetooth. Okay. This Bluetooth already has Kinana as admin and Suj as another user. Let's log in as Suj. I only know this because I own the tags. I click continue and then I scan. And I have access because, as I said, Kinana and Muhammad and these passwords. And connection type is Bluetooth, as you can see on this decrypted text where we're printing the header. We have Kinana and Muhammad and Bluetooth for connectivity. We have that one. Now we will try with the Wi-Fi. No one is here yet. Let's log in as Kinana. I scan the same way. You can see that the connectivity is Wi-Fi. I'm gonna scan. Kinana is the new admin. So to conclude, this demo shows how our mobile app is application and device agnostic, meaning that
nothing is stored on the mobile app itself. Instead, they are completely from the NFC tags.
Our application can render any HTML code you supply it, which is stored on the NFC tags, as long as it follows the standard that we set, which contains the header needed, followed by the code itself.
And we showed on our demonstration that only authorized users can have access on the device, and their username and password and even the content is fully hashed and encrypted on the NFC, which makes it completely entirely safe to use. Thank you.
So,
Thank you.
Thank you guys for watching, and please feel welcome to ask any questions. We would like to also thank Dr. Ala for being an amazing supervisor and a mentor throughout the period of this project, and thank everyone for coming and listening in as well. Thank you.
Thank you very much for this nice presentation. Very interesting work. And I think we should open the question round, maybe with Professor Mohamed.
Thank you very much. Thank you very much, Muhammad, Joanne, and Kenana. Let me say that I have high expectation from your projects, and actually you fulfilled it very well. Thank you very much. Very nice presentation, very nice work. The way that you presented was extremely well. I felt really like I'm a very professional that talks a lot about and talks very well about the product. So this is very nice.
Thank you.
I have some questions trying to understand the functionality of the system itself. You mentioned too many things, and actually it seems like you covered too many aspects for the product itself. That looks very nice. So now I will tell you what I thought and how the system works, and maybe you can also So you have so you assume like every device, like for example your router, will come equipped with an NFC tag, that's right?
Yeah.
Yes.
Okay. And then once I have your app on my phone, like what Joanne did, then I need to enter the username and password. That's right.
Yes.
And how this first step, this initial step, how can I verify that Joanne has the access to this router, or it's like based on the first one that will access the system? This part I didn't get it well. Because Joanne said that I have somehow, I know the password of the device, something like this. But this one, I didn't quite understand it.
Okay. So initially, anyone can be the admin to the controlling of the device. And since we're using a router, I cannot connect to it if I'm not connected to that internet. So that is a requirement needed to connect to the router. My phone, the phone that I am using, should be connected to that router. So initially, yes, literally anyone can be the admin. And after the initialization of the admin, only the admin can determine who it wants to be as the other users.
And for example, if my phone is connected over 4G, not like Wi-Fi, and then I get close and then I check the NFC, will the app be able to get access to the NFC tag or not?
No, you can't.
Because it
You should be
depends.
connected to the router.
Because it depends on the device. If that, in our example, the device is a router, and in order to communicate with a router, you need Wi-Fi connection. So 4G or not, it doesn't matter. As long as you have Wi-Fi connection, then you can communicate with the router.
Okay. And for example, for the Bluetooth you mentioned, so every time for every device, I need somehow of connectivity before I can start working with it. That's right.
Yes.
That's what you mean. So every device needs to have any Wi-Fi, Bluetooth, or then this is the way that. So you're actually the NFC will have the information, but the way that you access the device itself or the configuration, like when you try to change the password or change the SSID, is this done through the NFC or done to the Wi-Fi connection?
It's through Wi-Fi. It's actually through SSH. So we're sending SSH commands to to the router.
Okay.
Over
So to understand this better, so how this is different from someone who has the username and password for this device? They can connect directly to it. That's right. So if I can access the Wi-Fi, okay. So if someone has a username and password of the router, can do the same. That's right.
If their username and password is added into the NFC contents. Only then you can yes log into the router, but then you need to either be the admin, which is the first scan needs to be your phone, or the admin needs to add your username and password so you can access it. Otherwise, there's no way you can get access.
Okay. So can you tell me this also maybe? So what the initially NFC tag? What kind of information is like on the NFC tag? Does it have any information?
Okay. Suj, can you go to
So initially, when I bought the NFC tag,
Yes.
I have a router. Then I start like with an NFC tag. So what's the initial information on this?
Okay, so here, and if you can see the slides, in the decrypted text, initially we have this header, okay? And the number of paired devices in this case is 0, and the number of paired ID is none, and the password is also none. So initially, we check the parameters in the device's ID. If it is none, that means that the first scan, whatever username and password I use there, I will make that admin.
Okay. Okay. So this means like if someone if I get it right, if I'm in a mall, okay, in a mall, outdoor place, and I'm connected to a Wi-Fi access point, a Wi-Fi network, and you have this NFC tag, and nobody have touched this NFC tag before, then this mean I can get an admin right to this router?
Yes, technically yes. If you scan the NFC and you're in proximity of the router that you have Wi-Fi signal, and the NFC tag has not been scanned at all, you're the first one to do it, technically your credentials would be added into here. That's
Okay.
correct.
Okay.
But in an
Okay,
ideal
that's
or
fine.
normal
That's fine.
situation, that won't be the case.
Yeah, that's fine. I'm just trying to, because actually you can configure them to be, whenever you put them in a mode, you're not going to put them like this. You most probably need to, you make sure that only admin people can do this. Okay.
Yes, correct.
Yes. So I'm just trying to understand how the. So now, if I want to add another user, this part also I didn't understand because you were showing like a video where like you have admin. This one. Yeah, this one exactly. This animation. So if now I want to add another user, okay. So I need to understand how the admin will give access to the user to access the NFC. So there is a communication between the two cell phones.
So
it's
technically
one phone.
no. Go ahead, John.
Because I was confused because it seems like there was some like direct connection between the admin and the user.
Yes, this is one phone, and all the user authentication are stored in the NFC tag. Nothing is stored on the app, nothing is stored on the phone. So when the admin adds a new user, he will write to the NFC tag. And after that write, the new user is already stored in the array of paired devices as shown earlier. So on the next scanning of the NFC, when our app checks for the array of paired users, we will see that this new user has been added. So we're gonna give authentication to him.
Okay, and so my question now, the admin will add this information on a FC card, like the user information. So this, how does he add it? Like it adds through NFC also or through the Wi-Fi link? So how does he write on the NFC card? It's
just NFC, no internet connection needed.
So I can so this means like I can update the NFC card with this your software through this, I think, which one? This okay. So you can write on the NFC card. That's right?
Yes.
Okay. Okay. So now Okay.
That is through React Native. No internet connection needed.
Okay.
Just scanning. Yeah.
So you mentioned that the main objective was decoupling. So can you explain with this setting how did you achieve decoupling exactly?
So the idea is that the application, the mobile application, when you started, there's nothing, you're not connected to anything, so it doesn't know anything. It gets all the information, everything that it needs, even the user interface, the commands and functionality, all of that, it's stored into the NFC. So each NFC is essentially its own app. And once you scan that NFC, you get a completely new app, completely new functionalities. Everything is completely, like, entirely different. And it's all written in HTML, like the contents of that, like, application, the user interface, the commands that this device needs, if it's a router, if it's like an air conditioning unit, if it's whatever it is, a TV. It has all of the user interface that the manufacturer wants it to look like, and the functionalities that it needs. If it needs a button here, or like a something here, or a switch there, that's all based on their manufacturer. They can do whatever they want and however they want to customize their app look and functionality. Our application reads this NFC and renders it for the user. So this makes, like, the application decoupled. It's application agnostic. So it's not reliant on any external information. The only thing that it needs is the contents of the NFC, and it doesn't store anything within itself. It's not.
Mhm.
It doesn't keep anything within itself. There's no data stored into the application.
Okay, so what you mean like the other the NFC will have a code, okay, which
Yeah.
like somehow relate to the device, and your app will be able to understand this code, uh, and then this code, like for example, you will be able to run an app or what? And I didn't get this one. So on the NFC device on the router,
Mm-hmm.
because so it has mainly what I've seen from your application. The part
Mhm.
that you can actually change on the NFC is the admin rights or the admin user right. Do you have more information that is actually installed in the NFC,
Yes.
Yes.
which is
The HTML code itself.
which is like
So,
the
can
configuration
you?
that the configuration that you showed to me was actually based on this when you change the SSID and the Wi-Fi. This is done. This code is on the NFC, not within the Wi-Fi router itself.
Yes, these are all on the NFC. Suj, can you go to the demo maybe
Okay.
during the last few minutes of the demo? Maybe Kinana,
See
you
that the
want to explain that?
Yeah. So basically, wait.
Yeah. So here. Mm.
Here, so all this, the decrypted text, all of this
Mhm.
is stored in the NFC, and that's in HTML and JavaScript and CSS. So like all this code that's stored on the NFC that's shown here, decrypted text,
Mhm.
will be rendered by our application.
And this is where you're showing that where this is where you're able to change the SSID and the password.
Yes.
Yeah.
Okay. So
So
this is
this
like
one, for example, is with the Wi-Fi, and if you go zoom out a bit, Suj, the interface will be different, and that's where we show the HTML. So here, Bluetooth, let's say, an example only. So here the
okay.
connectivity is Bluetooth, the user interface is different, all the
Mm-hmm.
functionality is different. And then if we use another card again with another interface, it's going to show something different again. It
Okay.
doesn't depend on the, yeah.
So this interface is kind of give you like a user interface to access the parameters of the device itself.
Yes, yes.
Yeah.
Because I was confused because of the Wi-Fi router. Maybe I thought like you are trying to access because with the Wi-Fi routers we have a software that you can connect to it and then change the username and password. But what's
Mhm.
done here that your NFC code has this kind of extra interface where you can access or you can change the user. I think maybe the fundamental information or the basic information that needs to be changed by an admin or a user, and this will be reflected again or be transmitted to the router itself. Am I correct?
Yeah.
Yes. That's it.
Okay. Okay.
Mhm.
That makes sense for me. Okay.
Very good.
Okay, okay. Thank you. It was very interesting. I was trying to understand how does it work.
Thank you, Dr.
But,
Mohammed, of course.
Thank you.
So much.
okay,
We appreciate it.
thank you.
Of course.
I'm done. I'm done, Dr. Yan. Thank you.
Thank you very much.
Hi.
Maybe next.
Hi.
Can you?
Hi, Joanne and Kenan. Mohammed, it was an amazing presentation. I was really, really happy. It was very clear. And Mohammed, they asked several questions. I think we covered almost everything. Just I have few small questions and one technical question, please, if you allow me.
Of course.
So first question, yeah, your application can be installed in any mobile with low
Yes.
performance, anything, right?
Yes,
That don't
yes.
require too much memory.
No,
As you said,
and
most of the
because
memory
it's
will be on the NFC.
no, not at
Yes.
all. It's very, very small. The only thing it's really technically the only thing it's doing is it's reading NFC content and it's rendering it on the page. The application itself it's small and also we're doing it on React Native, so we have iOS and Android, so we have
Great.
cross-platform as well.
Okay, and what is the capacity of users? I mean, number maximum that can be registered.
You can have as many as you'd like. It's just
Really,
it adds on into the array of users and passwords, so there's no limit.
Until the NFC can no longer store what's the data.
Yes, because we have 32 kilobyte size of NFC.
Okay, great. And just tell me about the technical side, about the hashing function, how it works. More technical details if you have.
So we used a plugin in React Native. It's just called React Native Hash, and it uses SHA-3 algorithm. I think we explained it in one of the slides. If you can go, Ahmed. Yeah. This function, the one on the top, that's the one that we used.
Exactly. Yeah.
And it uses kickhack or SHA-3 algorithm for hashing.
Okay, yeah. Okay, this is what I want to do. Yeah, here. Let me just read it carefully. Yeah. The random key is 16. Okay. Yeah, I think that all. Yeah, I think it was amazing. Yeah, it's covered all the aspects. But just maybe how secure your applications. Yeah. If you want to measure it, if I'm the industry and I want to buy it, I ask you just a general question: how secure your application is?
Okay, so for normal users, it's pretty secure, but then for professional hackers, of course, it's not. As I mentioned in our trade-offs, one of our trade-offs is that even though we are encrypting and hashing, we are vulnerable to ramp dumping attack because, as we mentioned, in order to authorize users, we check the contents of the app. And when we check the contents of the app, the header, our app decrypts the message, the encrypted message. So if the hacker uses our application to check the contents of the NFC, then they can do that. And we acknowledge that limitation. And so we plan on making it better in the future by developing a better user authentication, probably most likely using an online database.
That's great. Yeah. Okay. For me, that's all. Yeah. Thanks a lot. Yeah. It was amazing presentation and amazing application. Yeah.
Thank you.
Appreciate it.
Thank you
Thank you
so
very
much.
much.
Thanks a lot. Thanks a lot. Yeah. Well done. Yeah.
So James has some questions as well. Go ahead.
Yes. First of all, Joanne, Mohammed, and Kinana, well done. Very interesting project.
Thank you.
I think I also agree with Dr. Shamir and also Mohammed. You all did a really good presentation. I almost get confused. The demo is a live demo, but end up I realize it's actually a recorded demo video. But it is really good presentation.
Thank you.
So I think most of the question actually I have being asked by Dr. Mohammed and also Samir. But I still want to follow up a question. I think have you all evaluate what's the maximum number of users that you can able to support or add inside the NFC?
The thing is,
any rough number?
So for the number of users, it's really dependent on, because at the end of the day, the NFC it's 32 kilobytes of size, and it depends on how many characters the usernames and passwords are. So if you have a long chain of usernames, then you're gonna have less users. But if you're gonna have less characters for usernames and passwords, then you potentially can have more users. So it's kind of difficult to approximate that, you know.
I see. So any rough number, let's say, is possible to support, say, 100 of user or 1,000 of user?
We didn't really put a limitation on that, and it mostly depends on how long the HTML code they want to put. So if the HTML the manufacturer supply is less, then there's going to be more room for the header and adding users, right? But then if the HTML code the manufacturer supplied is long with a lot of functionality, then there's less room for users. So it really depends on the manufacturers in that
I
sense.
see.
Based
All right,
on like a
because
quick like calculation, you can have approximately from 160 to 220 users.
I see. All right. The reason I'm asking this because I can see the beauty of this kind of idea, which is actually providing the serverless authorization and control for the Internet of Things. But for example, like for Wi-Fi servers, let's say in a hotel, like right now I am, right? You can easily have more than 200 users. So it will really affect the potential of your application. I think if the maximum number of the user can be scalable, then I think that will increase the impact of the idea. So I think that's the first question and I think comment. And the other question, which I think might be a bit challenging, because I think Mohammed already asked you quite details how the user is actually being added into the NFC, right? So you also give an example trying to add Mohammed into the NFC for the access of the router service.
Yes.
So what will happen if someone want to access a router service or a particular object, but the admin is not at the same location? Let's say Joanne is right now in another location. So how the NFC tag actually saturate at the same location as the new user can update the new user inside the tag?
So I think the requirement for like working on the application, it should be so that the users are all in the same location and in proximity of the router. So they can't be in different locations. If the admin needs to add a user, they need to be connected to the same router so that they can control it.
So that means if a new user wants to use the service, and the admin must be also at the same location in order to update the tag for the new user, correct?
Yeah.
Yes.
So the main idea is that the NFC tags are not tags. They need to be embedded within the device that we want to configure. So if you're not close to the device, how can you tap onto the NFC tag? So that's also one of the security measures that we took. That's why we chose to use NFC tags, because it only allows for short range of communication. So only those users that are actually near the device can configure it.
I see. I think that's what I could easily predict as a situation. I think the beauty of your project and idea is actually allow the serverless, or I would say cloudless infrastructure, right? But on the other side, there also limit to, I think when comparing to the current infrastructure, people can remotely add a new user, even though the admin and the new user are in the same location. So I think this is a trade-off, right? You want the service, but at the same time, you limit the possibility for the deployment, also a certain extent of the applications. So now, the challenging part is any possibility that you guys can think of, even though the admin, like Joanne, now everyone is like staying home right now. But if we want to grant the access for the new user at a location, is there any chance that you guys can come up, can remotely adding the new user, such that you can really unleash the potential of this serverless approach?
I think for that to happen, we would need to go online somehow. We would need to have some back end server that would take care of that, because then if then that defeats the purpose of having an NFC tag to begin with, because what's the point of you tapping your phone into the device physically when you can access it without doing so remotely, right? So if we
Yes.
have a backend server, then it would give us that capability, which is part of the idea of our future implementation of future developments of this project, is to have some sort of an online database or server, so that we can make that a possibility, what you mentioned.
Well, I personally see some possibility on this, right? But I think I will leave this for you guys. Just imagine if the admin is in another location, so everyone is using the phone. So at the moment, maybe you, Joanne, as an admin, can send a protected token to grant a pass for a user at a location, such that it can be temporary to add the new user into the NFC, but through the new user to update the entry in the NFC. And I want you guys to think about this. It's a bit challenging, but the idea is of serverless authorization and control for the Internet of Things, I think is really interesting and awesome. But on the other side, in order to support the current practice, in this case, how you can actually make the application can be supported by this approach to have a wider scale of the application. I think that's the beauty, if you can come up something that you can still remotely update the data in NFC. So I think this is a very challenging part. So I like the idea. And I think the last question I would have is, what happened if someone realized there's NFC there and intentionally and unintentionally take out the NFC tag? So what will happen to the surface at the location?
It shouldn't get affected because the NFC tag, it's alone. It is connected to the device initially, but if it got removed, it can still be scanned and configured. Then you can configure the device.
Will this be a concern of physical, I would say, security attack?
If he's my neighbor, maybe, and he can connect to the Wi-Fi with the NFC tag he stole, it can be a physical threat. But then that involves him stealing from my house, which is like crime.
Yeah, it's very difficult to physically like to protect that physical stealing of the NFC.
I see. So I guess it's pretty much targeting the application, like a home usage, Internet of Things, or maybe office
Yes.
kind of things, rather than the public infrastructure, right?
Yeah.
Yes.
Okay, great. Yeah, I think these are the two, I think, very challenging questions I can come up, and I know that you guys may not didn't actually put inside your idea yet, but I can see if you guys can address this too. I can see a huge potential of this kind of, I think I would call your project as like a serverless for Internet of Things. I think it's a really neat idea. So that's pretty much my question and comment.
Thank you.
Thank you.
James. We like
Well done.
your ideas as well, and we think that it's a great thing to implement those in our project. Thank you.
Yeah.
Well done, yeah. Well done all.
Thank you so much.
Thank you.
Thank you.
So before I give it to Ala, I just wanted not a question but a comment. So normally what happens is, first of all, never walk home just with the NFC tag. Take the router as well while you're at it. And the other question is, or comment is, so if you have this device there I think you need a NFC writer inside the router as well, because you need to be able to do a factory reset in case you forgot the password. So you need a switch, and then once you prove that you have physical access to the router, it will give you a blank NFC inside. The other thing I couldn't help but noticing is if you do HTML and JavaScript, this is all a lot of text. And my suggestion, moving this into maybe even a commercial product in the future, is to strip out all of the blanks in the HTML and zip it. Just use a compressor, because that gives you roughly 3 times the space to work with.
That's true.
But otherwise, great project, and I give it to Ala for final remarks as the supervisor.
Thank you, Dr.
So yeah, I mean,
Thank you.
I asked the team so many questions through the past 2 semesters, but I would like to ask them one more question. You know,
Oh boy. Okay.
So, very simple question, guys. You know, very simple. So
Yes.
if I have, let's say, at my home, n IoT devices that I would like to control. So today, without your application, how many applications should I install on my phone to control those n different devices?
And application.
And applications.
How about in case of your application?
One application.
Just
That
one.
is the main point, you know, that you're trying to make all over, right?
Yes.
Yes.
Thank you very much, guys. You know, it has been really a great pleasure for me to have you. I mean, you've done a wonderful work. You know, it's really a delight to work with you. I commend you for your efforts. I am pretty sure that you're going to be successful in your future endeavors. So keep up the good work.
Thank you, Dr. Allah.
Thank
We
you.
appreciate
Thank
it.
you,
Thank you
Taco.
very much.
Thank you.
Thank
We
you so
appreciate
much.
everyone's comments. Thank you so much.
No.
Yes.
And also, good luck. And I just have one comment to everyone here. I would like to thank you, all of you, for coming. I'm so happy that I've been like the director of this program for 4 years now, and I can see all of you, most of you, graduating now for the senior design project. I'm expecting like really all of you will be great engineers, and hopefully our relationship will continue after you graduate. And maybe you can do research with us. I know that many of you are applying for masters. Hopefully we can continue with this, and whatever the direction you're going, we enjoyed really working with all of you, and wish you all the best. And I would like also to thank more Mohammed Souj, because he has done much more effort also in organizing many things, helping me a lot. Thank you, Mohammed, for your great effort with everyone here, and
It's my pleasure.
wish you all the best. Okay. Thank you.
so much. Thank you.
Thank you.
Mr. Mohammed.
Oh, yes. Thank you very much for all the great presentations. It has been a pleasure. And just so you know, we had a peak attendance of about 24 people despite coronavirus for 9 students working in these teams. I think this is a good number that we have attracted in terms of external people tuning in out of interest of these great projects. With that, I think we are done. Congratulations to everybody for a good presentation, and stay safe and enjoy the rest of the weekend. Thank you very much.
Thank you very much, Dr.
Thank
Jans.
you.
Very much
Thank
all.
you. Thank you.
Thank you,
Jens,
everyone.
thanks,
you.
James, thanks, Muhammad.
Yeah,
Thanks, on.
thank you.
Thanks,
all.
on.
Thank you,
Send
James,
it.
for coming, and all your questions were very nice, very nice. Thank you very much, James. Thank you.
Thank you, Mohammed.
Thanks.
Thank you, Mohammed.
Dr. Amin is here. How are you? Oh, this is good.
I just doing quality check.
Okay. Oh, you should
That
have
was
told
good.
us. This is like, yeah, you kill. When did you show?
Congratulations. It looks very impressive.
Yeah, it's yeah, I'm so happy with our students.
Very nice, very nice.
Thank you,
Yeah,
Dr. Amin. Thank you so much.
Thank you.
Excellent.
You started.
I'm very happy for you. Actually, I had them in my class. I'm very proud to have them in my class. I taught them already.
Yeah,
Good.
they're very,
Yeah.
very good. And also,
Yeah,
thank you. You
congratulations to all
started
of
it. Yeah, thank you very much. Thank you. It's very pleasure to have you here.
All right, bye-bye.
Bye. Okay,
Well
thank
done.
you.
Have a good day. Bye.
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 Bye. Thanks a lot. Bye.
Thank you.